We are the Iowa State University AGC Student Chapter.
Scott Nybauer. I'm the bridge rating engineer for the state of Iowa at the DOT. My responsibilities are taking care of the load capacities on bridges and determining what loads the bridges in Iowa can withstand. And with that, I review the permit request for the wind tower load. So that's my main duties here at the DOT. If you can get a long enough trailer, wide enough trailer, you can get almost anything over any bridge if you get the load spread out enough. So I can't tell you that there's X number of bridges in the state that can't handle that load, because each bridge is different depending on how the truck is configured. There are shorter bridges that will only see 2 or 3 axles at a time when a load goes over it, and they might be able to handle a 400,000 pound load just fine, but in reality they're not as good a bridge. And then there's a longer bridge that may be newer and in better shape, but because it's so long and you have so much load on it all at one time, maybe that bridge can't handle it. Sometimes you'll have power lines or signs or something in small towns that are hanging fairly low, and these trucks have to be aware of that. And as far as the power line, the power company has to be contacted, and they have to get out there and hold the power line up as the truck goes under. There's companies that have had to trim trees back on roads because the branches are hanging out far enough that the load's going to hit it. Turning corners is probably their biggest hazard. They just have a hard time negotiating real tight turns, so they have to be careful that they're not running over somebody's property. At corners you have stoplights and signs and fire hydrants and all kinds of things there that they have to be aware of. The software program that I use to do the routing, because it's a little unique, it's a map of Iowa. It's a graphical interface where you can just click the route and it follows the route on the map and checks every bridge along that route. And it does it really fast, but it's more powerful than what it really looks, because it's actually checking the capacity of every single bridge along the route that we've chosen, and then it tells you where the truck passes or fails the analysis.
Before the tower arrives on site, a foundation has been poured and set with anchor bolts to support the new tower. Power equipment to be installed inside the tower is placed before the placement of the first section. While these activities have been going on, the site superintendent has been making sure that the job is done practically, safely, and all the while keeping an eye on the schedule. Leveling and shimming occurs just before the tower is to be set in base grout. Grout is a mixture of Portland cement and fine aggregate, such as sand. The grout is packed underneath the tower to form a tight bond between the concrete and the steel flange. Other common uses for grout are found in bricklaying, joint filling, and anchoring tiebacks into the ground. Before any tower section is placed, it is individually lifted off the ground 10 feet in order to allow crews to power wash the area that was in contact with the transportation vehicle. After the section has dried, a coat of paint is applied to all areas that have been scuffed by the transportation activity. The tower is lifted by cables attached to the rigging points. The points are designed by an engineer and are placed such that the segments are balanced and can be controlled in the air. The engineer has to design for wind loads, the weight of the segment, and the allowable stress designed for that type of steel. Construction of the hub is done on the ground. This allows for crews to work more efficiently, but most importantly, safely. While the hub is being assembled, crews must pay careful attention to the balance points of each wing while picking. Efficiency is obtained by having a crew outside placing the wing, while there is another crew inside the hub prepared to tighten the bolts. As each wing is attached, dunnage material is used to make sure that the wings don't tip over the unstable hub and rotor combination. The nacelle is the heart of the wind tower assembly. The generator produces the power as the wings rotate and then transfers the power to the main grid for distribution. The nacelle could easily weigh in excess of 400,000 pounds. At these extreme weights, engineers must design special rigging in order to accommodate the massive load. Cranes with heavy lifting capabilities must also be used in order to make a safe pick. The rotor is set using two cranes. The heavy pick crane is used for lifting the rotor into place, while a smaller crane is used to balance the rotor. When the rotor has reached its installation height, the smaller crane can safely release itself. The careful coordination between both crane operators is vital in order to keep a safe working environment. When using two cranes, it is considered a critical pick. There must be very detailed coordination between the site superintendent, job site foreman, and the structural engineer to make sure that every unforeseen aspect is taken into consideration and planned before the lift. The rotor is lifted into place and bolted to the nacelle. A crew inside the nacelle torques all bolts and releases the crane's pick points. Final connections are made, and the crew checks everything to ensure proper installation.